Welcome to our pre-lab lecture. This is lab number 4, chemical reaction 1, empirical formula. In this experiment, you will use the data given on the data sheet to determine the empirical formula of a compound. What I want to do is walk you through the calculation, which I believe is going to help you. I want to show you how to determine the empirical formula of a compound, so that when you go ahead and complete the data sheet, you will be on your own in terms of filling in the table and showing the calculation. I want to share my screen here and walk you through on how to determine the empirical formula of a compound. First, let me share my screen and show you the determination of empirical formula using an example. I have an example on how to determine the empirical formula. I will use my whiteboard here to show you the empirical formula of a compound, but before we do that, let's define the word empirical formula. Empirical formula is simply the simplest form. Here, empirical formula is defined as the simplest form of, this is the simplest whole number, all right, whole number ratio. This is number ratio of atoms in a compound. That is the definition of empirical formula. You should be able to define empirical formula, simply the simplest whole number ratio of atom in a compound. There is another term here which typically goes hand in hand with the empirical formula, and this is the molecular formula. All right, molecular formula, abbreviated MF. All right, for molecular formula. This is simply a formula of a compound. You define this as formula. This is the formula of a compound giving the actual. All right, this shows the actual number. All right, number of atoms in a compound. This is how you define molecular formula. In the lecture, probably you'll be asked to find the molecular formula of a compound, and molecular formula, MF, is determined by multiplying the empirical formula by an integer or a subscript n, all right, where n is an integer, all right. This is the integer, an integer, taking the values 1, 2, 3, all the way to infinity, to got to be all numbers. This is determined by taking the molar mass of a compound. Typically, this is given molar mass in grams per mole, may be given this, of empirical, this is empirical formula mass. This is the molar mass of the empirical formula as the denominator should give you a whole number, which when you multiply by the empirical formula, open the parentheses, you end up with the molecular formula. We will not dive into determination of the molecular formula, but I just wanted you to give an idea of how the molecular formula is determined given the empirical formula. Sometimes you may be given masses of atoms in a compound. You may be asked to find the empirical formula from the percent composition of a compound. Well, before I showed you an example on how to determine the empirical formula from masses, let's see examples, all right, of empirical formula. Here, I'm gonna draw the parallel between molecular formula, all right, molecular formula and empirical formula, molecular formula and empirical formula. We can have something such as glucose, all right? This is glucose with the chemical formula C6H12O6. This is the molecular formula. Its empirical formula is CH2, or if you look at what happened is I divide everywhere by 6. Pi 6 give me 1, pi 6 give me 2, pi 6 give me 1. So this is the empirical formula of glucose. I can have benzene, C6H6 is a empirical formula is CH. That's an example of empirical formula dividing all sides by 6. It's not always that you divide by 6. I can have another compound here, dinitrogen, all right, dinitrogen tetroxide. You got to look at what is common among the, what is common in the ratio of nitrogen to oxygen. And this is its empirical formula, NO2. What is happening here is I divide both sides or all sides by 2. And I think this is the exercise you will do in the pre-lab assignment. Given the chemical formula or molecular formula, you are supposed to write in some questions the empirical formula. Look at what is common, and you divide by that greatest common divisor to get what? To get the empirical formula. The objective of this experiment is given the masses of compound, or I mean masses of atoms in a compound, are you able to determine the empirical formula? I'll give you a learning example here. Let's look at an example here on how to determine the empirical formula. Here is an example, all right? This is an example on how to determine the empirical formula. Our question is, if 1.500 grams of vanadium metal react with our oxygen gas to give 2.679 grams of vanadium oxide. This is the product. What is the empirical formula of a compound? If you look at what we are starting with, we are only given the mass of one reagent, but we don't have the mass of oxygen. We have the mass of vanadium, all right? So what we need to do here is determine the mass of each element in a compound. We have to determine the mass of each element in a compound so that we end up with the correct number of atoms. How are we going to find that? This is third grade math, which should be much easier for you to determine by looking at the, all right, by looking at the equation. All right, allow me to split my screen here a little bit, and we'll have question. All right, we'll have a question next to each, next to my whiteboard. Here is the question. All right, so how are we going to find the empirical formula? To start off with, you may want to maybe write the equation of vanadium plus or oxygen gas, the atomic. This is solid metal to give us vanadium oxide. We don't know what the value for X, what the value for Y is, and therefore we cannot balance the equation. Sorry about that. Let me just bring this right here, and you should be able to see the equation. You'll be able to see the equation right there. Okay. So here from this question, we know the mass of vanadium 1.500 grams. We don't know the grams of oxygen, but we know the mass of what? We know the mass of the product, 2.679 grams, 2.7. This is a question mark. There's a question mark right there. We want to know or determine the value for X, the value for Y, the simplest whole number ratio to get the empirical formula. In order to do that, I'll generate a table here, all right, by saying that this is the element right here. And here is vanadium, and here is oxygen. This is oxygen right there. Let's see mass of each element. We know vanadium is given 1.500 grams. Mass of oxygen is the difference between 1.500, 2.9 minus 1.5, and starts out to be 1.179 grams. How I end up with this value here is by subtracting the 1.500 from 2.679. The units are in grams. We are done with that. Next is to find the number of moles of each element. And this is obtained by taking the mass in grams of atomic mass. You get this value from the periodic table. So if I divide 15, 1.5, not 15, 00 over 50.9415. This is from the periodic table. This gives me 0.0294. This is the number of moles of vanadium. For oxygen, 1.579 over 16. Let me just round off that to 16. This gives me 0.0737. This is the number of moles of oxygen. I know you may think that, let's divide by 32 because it is oxygen gas. You just have to use the atomic mass of oxygen atom, which is 16 from the periodic table, or 15.0 99 is the same thing. Pay attention to the number of moles. Here is what? 0.0294, and compare this 0.07394. You divide by the smallest. Divide smallest, all right, smallest number of moles. So if I divide by the smallest number of moles, all right, 0.0294 over 0.0294, this gives me 1. And 0.0739 divided by 0.02994, this gives me 2.5. In empirical formula calculation, you do not round off the number of moles. What I mean by that is you do not round off these to make it 3, all right, the way you do in math. If it is 0.5, all right, if it is 0.5, you want to make it a whole number. How will you make it a whole number? By multiplying it across pi 2. So I multiply here pi 2, I'll multiply here pi 2. And the mole ratio here is mole ratio, all right, is 2 and 5. I'm multiplying pi 2. It's not always that you multiply pi 2, all right? Sometimes it's just a whole number. If it is a whole number, we just go by that whole number. And that the mole ratio is what I need to write down the empirical formula of my compound. So this will be therefore, all right, therefore the empirical formula is phi 2 and then O5. This is the empirical formula of vanadium oxide, all right. In your lecture, maybe you will have to use percentage. I'll leave that to your lecture instructor. You may also be given masses of 3. If it involves 3 elements in a compound, you need to proceed using the same fashion. I don't want to go beyond this, beyond empirical formula calculation, because that's the objective of this lab. Please read the relevant section in the lecture, how to determine the molecular formula, practice on that, so that you are well-rounded. What I want to do now is, having gone through the example, here you see the learning check, I want to just walk you through the data sheet. So let's see, where is my data sheet? I think it is, no, this is not it. Yeah, that's not it. Yeah, this is it. This is what I was talking about in terms of data sheet. Let's see. The data sheet here, all right, I will enlarge this so that you see the whole page. This is the data sheet for experiment number 4. It is available online. Already the data is given. Make sure you put your name, of course, you don't have the lab partner, the date. Here, somebody had to do the experiment and they already collected the data you need to determine the empirical formula of magnesium oxide. Here, you need to find the mass of, we need to find the mass of, you'll have to find the element just the way we did before, which is mass of what? Mass of magnesium. and mass of oxygen. So here is the mass in grams, all right? Using the data given here, all right, the data given here, if you know the mass of the crucible, dry crucible by itself, crucible and magnesium, you should manipulate this data to get the mass of magnesium by itself. It's not rocket science, all right? And please show your calculation, because you lose points if you don't show your calculation. So how do you find? If I know the mass of crucible and magnesium, find the difference to get the mass of magnesium. And from there, you can do what? You can find the mass of magnesium. To get the mass of magnesium, right here, to get the mass of magnesium, I mean oxygen, all right, or even before we get there, let's see number of moles. I'm gonna come back to mass of oxygen. Number of moles of magnesium is given by the formula mass of atomic mass, AM for atomic mass. You can get this value from the periodic table. This will give you number of moles of magnesium. Upon combustion, that is burning magnesium in the crucible or cooling down as per the demonstration in the video, all right, this is the mass of the magnesium oxide. At this point, oxygen has combined with magnesium, and this is the mass. You need to find the mass of magnesium oxide. So if I subtract the mass of our empty crucible, all right, from the mass of crucible with magnesium oxide, I'll get the mass of magnesium oxide, Therefore, mass of oxygen is given by mass of magnesium oxide. Mass of magnesium oxide minus mass of what? Mass of magnesium alone. All right, magnesium. This is, and please use all, you know, all the places of decimal you will get. So in other words, mass of magnesium oxide minus mass of magnesium will give you the mass of oxygen. That is the mass of oxygen here, line 4. All right, you may call this line 4. All right, that is line 4. How are you going to get line 3, mass of magnesium oxide? All right, let's just write here 3, mass of magnesium oxide. Mass of magnesium oxide, like that. That's line 3. Will be mass of what? Mass of magnesium oxide. This is oxide plus crucible. This is crucible minus mass of crucible alone. So this will give you line 3. If I know the mass of magnesium oxide and product, this is line All right. You are given here mass of crucible with the magnesium oxide product. You see it's right here, minus the empty crucible will give you the mass of the product by itself. So for line 4, you already have it there. All right. Now, moles of oxygen, just to give you an idea, number of moles of oxygen is given by the what? Mass of oxygen of atomic mass of oxygen. All right. This is from the periodic what? From the periodic table. You get that from the periodic table. If you know the mass of, moles of magnesium and moles of oxygen, more of magnesium to 1 mole of oxygen, you need to find the mole ratio. 1 mole of oxygen, that means you divide by the smallest number to get that, and then you write the empirical formula. If you do your math correctly, I don't think you will need to multiply by 2 the way I did in the previous example. Please attach your calculation, all right? Attach an extra sheet of paper showing your calculation. Other than that, that marks the end of my pre-lab lecture on experiment number 4. Wishing you all the best. I'll see you on Thursday for lab and taking the quiz. Thank you and have a nice day.